Hi kids, these are the review stations for evolution. Starting with station 1 here, the cladogram shows the evolution of land plants as indicated by fossil records. Question says, which discovery would challenge? This word challenge means to go against the validity. Validity means correctness of the cladogram above. So which of these statements would go against this, or in other words, may make this picture false? Let's go through these statements together. Statement A says, a large aquatic vascular plant about 200 million years old. So remember, how I read time is going to be across this axis is going to tell me the time, starting with 425 million years down here. And it tells me 380 is about right there. So let's go ahead and I'm going to highlight where I see vascular plants evolve right here. So let's follow that straight down, and that gives me a time that is right here on this yellow dot. So we'll go ahead and say about what time ago is that? I know looking at here it's going to be between 380 and 409, so I'll just call that 400. All right, so let's just call that about 400 years ago. Now, remember, whenever that we see a trait has evolved, so right here around this dotted line is when the vascular plants evolved. Also, everything that comes after it or evolves afterwards is also going to have that trait. So around 400 million years ago and everything after, I could find a vascular plant. So A says, if I find one 200 million years ago, which is up here, do I expect that? The answer is yes, I expect that. So that is not my answer. It is not going to go against this cladogram. I want you to go through B, C, and D with the same logic and see which one would you not expect to find. After you've done that, you should see that the end answer is D. All right, this next station here, guys, is station 2. We are specifically looking at the fossil record. It says of a mollusk. Now, that is unimportant, but we're looking at the changes in this organism over time. So, I just want to go through this fossil record with you. We know that I have the oldest fossils at the bottom, and the youngest ones are going to be at the top. Here I can see my organism in these first 4 layers. So these are the first 4 right here. I notice that my mollusk didn't change. So that means there is a period of no evolution in these 4 layers. So what do I think stasis means? Well, stasis clearly means stable or staying the same. I know the organisms stayed the same, so the environment must have been stable as well. Then let's check out what happened. If I go to the next layer, boom, there was a huge change. And we see that right here. There was a rapid change in the environment, which caused the characteristics of my mollusk to change. As you can see, my mollusk clearly got larger. And then they went through a period again of no evolution, a stable environment that stays the same. So this was, they got larger, remember, at the rapid change. And what I just told you, it looks like we have stability here. Some change, which made the bigger mollusks survive in that environment. And then again, no evolution. Correct answer, if you go through here, is letter F as in frog. Here, guys, the format is looking a little weird, I'm sorry, but As a reminder, we are looking at station number 4. I'll write it at the top. The description got cut off of the map, but the question is still here. It says, which statement about the ancestry of lizards is best supported by the diagram? So if we go back to the reading, it says the lizards first colonized this island that I circled in green. That island is the oldest. And it also tells me this island right here is the youngest. So I can tell you about how the lizards moved. It looks like they must have started here and eventually made their way to the furthest, most west island. What I want you asking yourself, the oldest island, their common ancestor had to come from somewhere. It didn't come from that island. So if you look here at the map, I'm going to circle in red, that you kind of zoom out, and remember, we know they started right here. Where is the most probable place that their common ancestors came from? Remember, water is a physical barrier, so they're not going to cross a lot of water. So my two choices here look like Spain and Africa. Now, Spain to Africa has a lot of water between it. So that's not a really good option. So they must have come from the only other option, which is Africa. Common ancestor came from Africa and then traveled outwards to the west. So the one that says that is letter C, as in cat. Last question, guys. This is question 5. It says, based on the information provided in the data table, which two species are the most closely related together? Okay, so that's our extension question. Our original question is right here in bold. This is station 5 again. The cladogram is based on which of the properties from the table? So again, this is my cladogram, the picture up here with the frog, bird, and horse. This tells me that these organisms are all related, okay? Or in other words, they all have a common ancestor. Now, how much space is between two organisms like this and this and this and this can tell me how closely they're related. The less space between them, the more related they are. The more space between them, the less related they are. So right here, I know the bird and the horse, those are going to be the most related. Okay? And what is least related here is the frog and the horse, since they're going to be the furthest away. So based on what we know by looking at the pictures, let's find out which properties from this table support that. So let's start with the external covering. We have moist, soft skin, feathers, and fur. Can I tell you anything about that these organisms are all related or how related they are? No, because all of this are different, so I can't use this to tell me about the relationships. Now let's look at the skeleton. They all have the same skeleton, a four-limbed vertebrae, meaning if they share characteristics, they came from a common ancestor, which is exactly what this picture told me. So I can use a skeleton to tell they're related. Let's look at the fertilization. We have the frog is external, and the bird and the horse are internal. Let me highlight that. So that is saying here, the bird and the horse is most related. If we go back up here, doesn't that support the cladogram of the bird and the horse most related? And then the frog and the horse are the least related. So that looks promising right there. We could use that to make this picture above. The last one, common ecological niche. Again, not very important, the meaning behind that. But let's look. We have wetlands, trees, and plains. Same as the external covering. Can we use that to tell relationships? No, because they're all different. So that doesn't give me any clues about who's related to who. So we're down to looking at skeleton and fertilization. And that is answer choice C, as in cat. If you'll remember, things with homologous structures means they are closely related, or they come from a common ancestor. If you see that word analogous, that is the opposite, where they do not come from a common ancestor.